Hello, and welcome to this week's STEM lesson. This week we will be discussing static electric charge. So, you approach the door of your friend's house. What's the first thing you do before entering? Of course, wipe your feet. You are a thoughtful visitor. Fortunately, there's a nice piece of carpet by the door to wipe your shoes off. After wiping your feet on the mat, you reach out to touch the brass knocker on the door. Ouch! A spark suddenly jumps between your hand and the metal. You just felt an electric shock. An electric shock occurs when there's a sudden discharge of static electricity. The reason you get shocked is because of moving electrical charges. Moving electrical charges also create lightning bolts. It is also the same reason electric currents flow through cables and wires. You can think about static electricity like a teeter-totter. Things are fine as long as they are balanced. The same can be said about electrons. Too many or too few can be shocking. Static electricity is all about balance. Charges can build up through friction. Some materials freely give away electrons. Other items easily take electrons. Have you ever rubbed your feet on a carpet? Rubber-soled shoes readily accept electrons. The carpet easily gives up electrons to the shoes. This combination provides for a large transfer of electrons. This buildup of electric charges is known as static electricity. Positive charges build up on the mat and negative charges build up in you. What happens when an object becomes charged? A material is likely to remain charged until it touches another object. Sometimes it will discharge if you just come close to another object. What comes next may be shocking. Electric charge is a physical property. It occurs between two particles or objects. It causes them to attract or repel each other. They do not even have to touch. All electric charge is based on the protons and electrons in atoms. A proton has a positive electric charge. An electron has a negative electric charge. Most atoms are balanced electrically. They have the same number of positive and negative charges. When it comes to electric charges, opposites attract. In other words, positive and negative particles are attracted to each other. Like charges repel each other. A positive and a positive will repel each other, and same with a negative and a negative. If two positive charges are brought close together, they will repel or go away from each other. The same is true with two negative charges. They too will repel each other. The force of attraction or repulsion between charged particles is called electric force. The strength of electric force depends on the amount of electric charge. It depends on how many electrons or protons there are. It also depends on the distance between charged particles. There is a greater electric force if there's a larger charge or the charges are closer together. Now think back to the beginning of the video when we talked about wiping your feet on the mat like a good friend does. What might happen as your hands get close to the metal doorknob? Remember that large buildup of electrons? The electrons suddenly flow from your hand to the knocker or the doorknob. The sudden flow of electrons is called static discharge. The discharge of electrons is the spark that you see. It's also the shock that you feel. So by now, you might be wondering if there are any other examples of static discharge. The answer is yes. There's one big one we haven't discussed yet. Lightning is a form of static discharge. It's much more dramatic than what happens between you and the door knocker, but it's the same principle. You have no doubt seen lightning in a rainstorm. What does lightning have to do with static electricity? As it turns out, everything. During a rainstorm, Clouds develop regions of different charges. This happens due to the movement of air molecules, water drops, and ice particles. The negative charges are concentrated at the base of the clouds. The positive charges are concentrated all the way at the top. The negative charge repels electrons on the ground below. The ground then becomes positively charged. Over time, the differences increase. Eventually, the electrons are discharged. This is what we see as lightning. Now, I hope you all enjoyed today's lesson, and thank you for watching, and we will see you next week.